Hello students, last class we have studied about or discussed about identify A, B, C, D type of some problematic questions. So these are also a series of reactions. Now we will solve some organic conversions. So for this organic conversion, what is this conversion? That means you have to convert one compound to another through a series of reaction. So for this you have to remember, you have to familiar with what are the preparation and properties of some compounds. So as this chapter is dealing with carboxylic acid, we have to familiar with what are the preparations of this general methods of preparation of carboxylic acid and what are the properties. Next, you have to also remember or keep in mind in this organic conversion, whether this reaction takes place either through oxidation or through reduction, whether number of carbon atom increases, that is step is increases, whether number of carbon atom decreases, that is step is decreased. So if the number of carbon atom increases, then you go through either nitrilation reaction or through Grignard's reagent or by Wood's reaction, the number of carbon atom can be increased. Similarly, if any cases the number of carbon atom decreases, then you go through decarboxylation reaction, and then through Hofmann-Bromamide reaction, then through Skimmed reaction like this. So keeping in mind what are the different preparation properties, we will solve this type of question. Let us first discuss one, formic acid to acetic acid. You know formic acid is HCOOH and acetic acid is CH3COOH. Here number of carbon atom increases. So as the number of carbon atom increases, I have to go through nitrilation or Grignard's reagent. Using this, I can increase the number of carbon atom. Look here how I solve this. So formic acid. So formic acid, when it is reduced with lithium aluminum hydride. First, you have to, it gives methyl alcohol. And methyl alcohol when treated with either PCl5 or PCl3 or thionyl chloride, SOCl2, it gives methyl chloride, alkyl chloride, and after this alkyl halide we can increase the number of carbon atom. And remember, in the organic reaction always you have to go through the smallest step reaction, the less number of steps, so that it is more effective. If the organic reaction is large, the step is more, then it is not effective. So formic acid, lithium aluminum hydride first gives methyl alcohol, and methyl alcohol reacts with phosphorus pentachloride to form methyl chloride. And nitrilation means you have to add potassium cyanide in alcoholic medium so that it gives methyl cyanide. So remember what are the properties of this. And this methyl cyanide, when undergo hydrolysis, it forms CN in acid medium or in alkali medium, it forms acetic acid. So this is the conversion of formic acid to acetic acid. Similarly, for the conversion of acetic acid, you have to, starting from acetic acid, you have to reach at formic acid. But you look here, this is not a reversible reaction. So you have to go through different reactions, so that series of reactions, so that you can convert from acetic acid to formic acid. So it is given vice versa. I am writing here formic acetic acid. So this is step is increasing. Then step decrease. Suppose I heated with when it is heated with NaOH and CaO, soda lime. Then what it gives? So first this is converted to sodium acetate. Then sodium acetate reacts with soda lime to form methane. So it gives you methane. And methane when treated with chlorine in presence of HNO, it gives what? Methyl chloride. And methyl chloride when treated with aqueous KOH, it forms what? Methyl alcohol. and methyl alcohol when undergo oxidation with strong oxidizing agent, when it undergo oxidation, strong oxidizing agent, potassium dichromate, in presence of acidified potassium dichromate, it gives formic acid. So this is acetic acid to formic acid. Previously I have written formic acid to acetic acid. Next, move to next question. Acetic acid to acetone and vice versa. Different methods are there. Suppose I write here 1 to 2 method, acetic acid to acetone. So look here, acetic acid when treated with thionyl chloride, first it forms acetyl chloride. Okay, and you know how to prepare acetone from this. When acetyl chloride treated with dimethyl cadmium in presence of dry ether, it forms acetone. This is one method, or another method is also there. Two-step reaction. Look here, acetic acid treated with calcium hydroxide, it forms calcium acetate, and calcium acetate when undergo dry distillation alone, dry distillation, it forms acetone. Okay, so this is acetic acid to acetone, either this method or this method. This is also two step, this is also two step. Any method you can write. Next, vice versa means I have to again prepare acetone to acetic acid. The simplest method for preparation of acetone to acetic acid is only oxidation. When acetone undergo oxidation, it forms, actually ketone do not undergo oxidation easily. However, if you use strong oxidizing agent like nitric acid or acidified potassium dichromate, etc., then it undergo oxidation to form carboxylic acid. So here bond breaking takes place. This part gives one acid and this part gives another acid, but still it undergo oxidation to form carbon dioxide and water. So only this part gives you acetic acid. Okay, so this is acetic acid to acetone and this is acetone to acetic acid. Next, move to next question. That is acetic acid to acetaldehyde. Very simple method. Acetic acid, same, reacts with either SOCl2 or PCl3 or PCl5. Last I have taken SOCl2, here I am taking PCl5, gives CH3COCl. When acid chloride reduced with hydrogen in presence of palladium barium sulfate and the solvent is xylene, it simply gives acetaldehyde. So this is the conversion of this. Another method also you can write. When acetic acid reacts with calcium hydroxide, form calcium acetate, and mixture of calcium acetate and calcium formate gives acetaldehyde. Okay, again acetic acid to acetaldehyde and vice versa means from acetaldehyde to acetic acid. So acetaldehyde when undergo oxidation in presence of acidified potassium dichromate, it gives acetic acid. Simple. Next, acetic acid to acetaldehyde, vice versa. Next, move to next question. acetic acid to isopropyl alcohol. Here look, carbon atom increases. There are also different methods by which you can convert acetic acid to isopropyl alcohol. Look here. So first you convert acetic acid to acetone easily. Acetic acid, then PCl5, acid chloride treated with dimethyl cadmium in presence of dry ether to form acetone, which on reduction with lithium aluminum hydride, this CO group is reduced to CHOH. It is converted to isopropyl alcohol. Then you can also write this another way. Look here, or this one. Suppose I write here SOCl2. Again it gives acid chloride. Suppose I reduced your hydrogen in presence of palladium, barium sulfate. It gives acetaldehyde. And you know Grignard's reagent. So here I am using Grignard's reagent. Grignard's reagent also increases the step. So when formaldehyde reacts with the Grignard's reagent, it forms primary alcohol. Except formaldehyde, any other aldehyde reacts with the Grignard's reagent followed by hydrolysis to form secondary alcohol. So I am here taking CH3MgBr in one step and another acidic hydrolysis. It forms, so this methyl group will come here, MgBr here, and hydrolysis after that. It gives CH3, CH, CH3OH. You know this reaction, I think. Look here. So first CH3 group come here, MgBr here. It gives addition product. O, MgBr, and here H is there and CH3, which upon hydrolysis H3O plus. So here bond breaking takes place. CH3, CHOH, CH3. So from this to this. So either you go through this or by this. Okay, this is also 3-step, this is also 3-step reaction. Next, isopropyl alcohol to acetic acid. Isopropyl alcohol. This is isopropyl alcohol. So when it is treated with copper at 300 degrees Celsius, so what will it form? Minus H2. Dehydrogenation takes place. It forms acetone. And from acetone to acetic acid, already I have discussed in last class, in last question. That is oxidation in presence of either K2Cr2O7H plus or through nitric acid give rise to acetic acid. So this is acetic acid to isopropyl alcohol and this is isopropyl alcohol to acetic acid. Next come to next question. That is acetic acid to ethane and vice versa. So here also the same number of carbon atom, acetic acid 2 carbon and ethane also 2 carbon atom. So here reduction takes place. This is acetic acid and ethane, you know, CH3, CH3 or C2H6. So this group is reduced to either to alcohol or to alkyl part. So when it is reduced to alcohol part, generally we are using lithium aluminum hydride. But if you use HI in presence of red phosphorus, this is the strongest reducing agent. So this strong reducing agent reduces carboxylic acid to CH3 group. So this is directly reduced to ethane, carboxylic acid to ethane, CH3, or I can write C2H6. Then ethane to acetic acid. So how will convert? C2H6. Simple chlorination, H nu forms C2H5Cl. And C2H5Cl, when treated with same number of carbon atoms, so no nitrilation here, aqueous KOH, C2H5OH. When primary alcohol undergo oxidation in presence of potassium acidified potassium dichromate solution, first it converted to aldehyde, then to acid. So containing same number of carbon atom. So this is acetic acid to ethane and ethane to acetic acid. Next, acetic acid to methyl. So acetic acid, carbon atom decreased here. So first suppose I treated here with NaOH, form sodium acetate. And sodium acetate when treated with soda lime, this CH3 combines with this hydrogen, it forms CH4 minus Na2CO3. No need to write the side product, only you have to write what are the main products or important products. So this is acetic acid to methyl. Next come to how we can convert methane to acetic acid. Methane, CH4. So methane to acetic acid means number of carbon atom increases. So chlorine, H nu gives CH3Cl. Then simple nitrilation, cyanide, alcoholic generally, gives CH3Cl, and this cyanide again undergo hydrolysis in presence of acid, dilute acid, to give acetic acid. Okay. Next, come to next question. Acetic acid to ethylamine and vice versa. Here same number of carbon atom, that can be done by various methods. Look here, one method. Acetic acid when reacts with ammonia. I have to go through what are the properties. What is the starting material given? Its chemical reaction. What is the ending reaction? Ending chemical given? Its preparation. You have to remember. So this is acetic acid. Ammonia forms ammonium acetate. When ammonium acetate heated, it forms removal of minus water is there. Removal of water molecule. It forms amide. And when this amide treated with lithium aluminum hydride, it forms ethylamine. This can be done by another method. Look here. Acetic acid when treated with lithium aluminum hydride. This is another alternate method. First it gives you alcohol. And when this alcohol reacts with phosphorus pentachloride, it forms ethyl chloride, and when ethyl chloride reacts with ammonia, it forms ethylamine. So this is also 3-step reaction. This is also 3-step reaction. You can write anyone. Next is vice versa. That means I have to again convert ethylamine to acetic acid. So how to convert ethylamine to acetic acid? Look here. So when an amine reacts with nitrous acid HONO. Generally this is not a stable acid. It is prepared at the time of requirement. So generally how this is prepared? This is prepared by the reaction of sodium nitrite in presence of dilute hydrochloric acid. So these two mixture gives nitrous acid. So when ethylamine reacts with nitrous acid, it forms ethyl alcohol, and ethyl alcohol under oxidation in presence of potassium dichromate forms aldehyde, and aldehyde on oxidation with acidified potassium dichromate gives acid, carboxylic acid, containing same number of carbon atom. Either from this alcohol you can write oxidation 1-step reaction, or you can write in 2-step reaction. Okay, but this is aldehyde as the intermediate step. I have written in 2-step reaction. This is the conversion of acetic acid to ethylamine, and this is ethylamine to acetic acid. Okay, third one is ethylamine to acetic acid. Next move to next question. Acetic acid to methyl alcohol. Look here, acetic acid to methyl alcohol, here what? Carbon atom decreases. So I have to keep in mind carbon atom decreases. So first, acetic acid, either Dumas method or through Hofmann-Baumann reaction like this. So acetic acid when treated with, so first I am writing here ammonia. It gives ammonium acetate, and ammonium acetate when heated, it gives acetamide minus H2O, and when this treated with bromine and KOH, aqueous KOH, when it is warmed with this, when an amide treated with bromine and aqueous KOH, it forms, when an amide reacts with bromine and aqueous KOH, it forms a primary amine. This CO group is removed and CH3NH2 is there. And CH3NH2, methylamine, and this methylamine when treated with nitrous acid, it forms methyl alcohol. Okay, another way also you can prepare. Look here, I have told you that either Hofmann-Baumann reaction or through scheme reaction or through Dumas method, decarboxylation method. Let us discuss what is the decarboxylation method. This is acetic acid, sodium hydroxide, first forms. Okay, and when this is treated with, heated with sodium hydroxide and calcium oxide, it forms methane. And methane when undergo chlorination, it forms methyl chloride. Methyl chloride treated with aqueous KOH forms methyl alcohol. So 1, 2, 3, 4. 1, 2, 3, 4. This is also 4-step reaction. This is also 4-step reaction. Any reaction you can write. Next come to another vice versa, methyl alcohol to acetic acid. So as methyl alcohol to acetic acid, number of carbon atom increases. So first methyl alcohol reacts with PCl5 or phosphorus iodine or PCl3 forms CH3I. Then this treated with CH3Cl. PCl3 give rise to CH3Cl treated with potassium cyanide CH3Cl, which on acidic hydrolysis forms methyl alcohol to acetic acid. Acetic acid to methyl alcohol, acetic acid to methyl. These two are alternative method. Here also some alternative method, but I don't want to waste time. Just I am giving one method. Next come to you can also choose what are the other step reactions, but that should be a true chemical reaction. Okay. Acetic acid to methylamine and vice versa. Look here, already in last class, last question I have discussed this one, acetic acid to methylamine. This is acetic acid, ammonia, ammonium acetate, heat gives acetamide or ethanamide, then Hofmann bromamide reaction gives, this is conversion of acetic acid to methylamine. Next come to methylamine to acetic acid. This is methylamine treated with nitrous acid. Maximum reaction, alkyl halide is the intermediate. So in this way you have to convert into alkyl halide. Methylamine nitrous acid gives methyl alcohol. Methyl alcohol reacts with phosphorus pentachloride, methyl chloride. Methyl chloride treated with potassium cyanide, methyl cyanide. Methyl cyanide undergo hydrolysis, forms acetic acid. This is methylamine to acetic acid. Next come to next question, acetic acid to ethylene and vice versa. Here also same number of carbon atom. So ethylene that can be prepared from alcohol and acetic acid can be converted to alcohol easily. Keep it in mind. So acetic acid when treated with lithium aluminum hydride forms ethyl alcohol, and when ethyl alcohol treated with concentrated sulfuric acid at 443 Kelvin. Here H, here OH, removal of water molecule takes place and it gives CH2 double bond CH2. This is acetic acid to ethylene. Next vice versa, ethylene to acetic acid, ethylene. So first we prepare ethylene to ethyl alcohol. This is the dehydration process. This is the dehydration process. This is the reduction process. Reverse. So you add water molecule and then undergo oxidation. So this is your ethylene when treated with water in presence of sulfuric acid. So first actually it reacts with concentrated sulfuric acid to form alkyl hydrogen sulfate, and this ethyl hydrogen sulfate, and this ethyl hydrogen sulfate then treated with water, it forms alcohol. So directly I am writing here concentrated sulfuric acid and second by water. It is converted to ethyl alcohol, and ethyl alcohol on strong oxidation with oxidizing with acidified potassium dichromate converted first to this, then on oxidation with gives acetic acid. This is ethylene to acetic acid. Then come to acetic acid to acetylene and vice versa. In this step, this is somehow first acetic acid, same reaction we have to go through. Acetic acid, lithium, aluminum hydride gives. So first for acetic acid to acetylene, first I have to go through up to this. I have to prepare first ethylene. So in this way I am not repeating here. So just to this equation again I am writing. So first it is converted to ethylene. Acetic acid to ethylene, and when it is treated with bromine in presence of CCl4. So what bond breaking takes place here, and here one Br here. So it gives rise to CH2Br, CH2Br. This is the proton 1,2-dibromoethane, and when this is treated with alcoholic KOH, dehydrohalogenation reaction takes place, hydrogen halogen and hydrogen halogen. In this way it forms acetylene. So acetic acid to acetylene. Next, acetylene to acetic acid. Look here. Acetylene, this reaction already you know, when it reacts with water in presence of sulfuric acid and mercuric sulfate. Dilute sulfuric acid and mercuric sulfate, it undergo hydration to form acetaldehyde. Okay, and acetaldehyde when undergo oxidation by potassium dichromate or Tollens reagent, either potassium dichromate or potassium permanganate or Tollens reagent also, it gives acetic acid. So these are some aliphatic organic conversions on chapter carboxylic acid. Next class we will discuss about some aromatic or organic conversions relating to this carboxylic acid chapter. Okay.